This is our first of this series of my videos on definition of derivative, what you will need to be able to do on your skills test regarding the definition of derivative, and hopefully you're watching this after you've watched the video from Hippocampus. So you're going to be looking at the PDF file that goes along with this video. If you've not printed it out, you may want to go ahead into the Blackboard folder and print it out, pause the video here, and come back. Alright, so in the first box here, what we want to do is look at what the definition of our derivative is algebraically. So our derivative, and the notation that I'm going to use, is f prime of x, the derivative of this function, right, f of x, whatever it is, and we're going to look at many, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And I'm hoping that from the Hippocampus video you remember that this is really another way of looking at the average rate of change. And also, if you were in 171, you know the difference quotient. This h is just that difference between the x values. But we're going to take now in calculus the limit as h approaches 0. We're going to call that our first derivative. And one of the other things that you probably picked up, hopefully, from the Hippocampus video was that that's actually the slope of the tangent line at any point on the function. Right? That's what we were looking at there. It's the slope of the tangent line to a point on f of x. Well, the other thing that it is, if that's our first thing, the second thing is that it is the instantaneous rate of change, the IRC, at any point on f of x. So these are the three things that we talk about when we talk about defining the derivative. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. It's also the slope of the tangent line at a point on the function and the instantaneous rate of change at any point on the function. The only other thing that I'm going to add to this is that we have several different notations that we use for derivative. If I'm talking about the derivative of f of x, you can see already f prime of x, and this is also included in another PowerPoint I've asked you to go through. Maybe dy over dx, we use this notation a little bit more when we get into antiderivatives. Sometimes you'll even see y prime. They all mean exactly the same thing. So please take the opportunity now and fill out your form, this PDF file, if you have not done so. Alright, so we're going to start going through 4 problems that are on your document. And you can see at the top here that I've gone ahead and I've rewritten out our definition of derivative algebraically because that's what we're going to use. And notice that what's going to happen is I'm going to go through and say, alright, let's work on the top of our algebraic function there, the f of x plus h minus f of x. Then we know that the bottom of it is h, and then we're going to take the limit as h approaches 0. So in this first one, where you see f of x is equal to 2x plus 3, the very first step is to determine, let's change that, what f of x plus h is. So f of x plus h simply means to plug in x plus h wherever we see x. It looks like this initially, 2 times x plus h plus 3. And then of course we will want to simplify that, and we're going to say 2x plus 2h plus 3. So that's our very first step. We just evaluate x plus h. Now we're going to subtract f of x. And notice that I'm going to do this, I'm kind of lining it up vertically. It just makes our work a little bit easier. F of x is actually 2x plus 3. And notice that I've lined these up right under where they appear in f of x plus h. Because if we're going to subtract, the beauty is these pieces, if we've done it correctly, fall out. We're left in the top with 2h. Well, the bottom is actually h. The next thing that we would do is simply reduce. And now we're looking at the limit as h approaches 0 of 2. Well, the limit as h approaches 0 of 2 is simply 2. So the derivative f prime of x is equal to 2. And that's how we start looking at our derivatives. Now, those of you who've already had some derivative work, you know that a shortcut gives us that too, but I'm not going to go there quite yet. So that's the answer to our first one. Okay, let's move on to our second example. G of x is equal to 5x squared. So g of x is equal to 5x squared, and we want to find the derivative g prime of x. So again, we're going to start the same way. We're going to start by finding g of x plus h. And all that means is we're going to take x plus h and plug it in for our x in our original function. So that's what it looks like at first pass. Please remember this idea of x plus h squared. You know, you can look at it just back the old way. I know some of you talk about FOIL, some of you talk about box, but that's basically what you're doing. You've got to come up with x plus h times x plus h. And when you do that, it's x squared plus 2xh plus h squared. And now what we want to do is let's just simplify a little bit and multiply our 5 through. So 5x squared plus 10xh plus 5h squared. The next thing that we want to do is we know that we want to subtract our original function g of x. G of x is simply 5x squared. When we draw our line there, we're going to subtract. These pieces are going to fall out, and we're going to be left with 10xh plus 5h squared, and again, that's the top of our difference quotient. Finishing this up, we know that the bottom of our difference quotient is simply h. And now what we want to do is we want to reduce this. So hopefully each of you remembers a little step from pre-calc where we just reduce out the factor of h. When we do that, we're left with 10x plus 5h. All right, now what we need to do is we need to take the limit as h approaches 0. Well, the limit as h approaches 0 for this function, we can simply plug in a 0 for h. That piece is going to go away, so our derivative, g prime of x, is going to be equal to 10x. As I start this next one, I want to make sure that you understand that we're not going to do this definition of derivative for much more. This definition of derivative really just helps us understand where all of our beautiful shortcuts come from. There is one question on the test where I ask you to find the derivative using its definition, and this would be the process that you would go through for that. Okay, so let's get started on this next one. So here, we're first of all going to find h of x plus h. All right? Don't let the two h's confuse you. H of x is simply our function, so this is basically going to say x plus h squared minus 7, and hopefully everybody now knows a quick way to square this little piece out here. Square the first, multiply and double, square the last, and then our minus 7. So that's what h of x plus h is. We know that we're going to turn around and subtract our original function, and our original function is x squared minus 7, and remember I'm using that technique where I'm going to line these up right under where they are from the x plus h evaluation. When I subtract, they fall out. I'm left with 2xh minus 7, oops, excuse me, 2xh minus h squared, or 2xh, let me try that one more time, 2xh plus h squared. These pieces don't have anything underneath of them to subtract. This piece fell out, this piece fell out. That's the top of our difference quotient. We know that on the bottom of our difference quotient we have an h. Our next piece is to reduce that. We want to reduce our difference quotient. So we know in this case that the h's actually reduce out, and we are left with 2x plus h. Now what we want to do is we want to take the limit as h approaches 0. Again, if I see an h there, I know it's going to evaluate at 0, which tells me that the derivative h prime of x is equal to 2x. And that would be the derivative of the function h of x is equal to x squared minus 7. So why don't you go ahead and try to work through number 4 before you continue with the video. Go ahead and press pause here, see what you can come up with, and then see how I work through it. So the first thing that I do is I go ahead and I'm going to look at k of x plus h, and you can see that I've taken, and this was my original line where I just plugged in x plus h, and then this is my line where I've really simplified it. Now you can see that I've taken and lined up the original function k of x under its matching values. We know now that these are going to reduce out. So to finish this, you can see that I've taken now and I've subtracted, and I came up with the top of my difference quotient. I've put it all over h. When I take and I reduce that, I end up with negative 6x minus 3h plus 9. But I know that I'm not finished with the definition of derivative, because what I need to do finally is take the limit as h approaches 0. And remember, when I'm taking the limit as h approaches 0, that simply means anything that has an h in it I can evaluate with 0. Leaves me with negative 6x plus 9. Negative 6x plus 9 is the derivative of k of x. What you need to understand from this video is all of the shortcuts that you will learn next are derived from this definition of derivative. Again, on the test, I will ask you one question about finding the derivative using its definition.